All right, boom. So, welcome back to another video. Today we're doing the very last project in the free code camps data analysis with Python. So we're doing the C-level predictor. So with this one, what we're gonna do is we're gonna import some data from a CSV file, and we're gonna use Matplotlib to create a scatter plot. Then we're gonna do the linear regression function on it, and then find the best fit for the years up until 2050, and then also we're gonna plot a new line for the best fit using the data from 2000 through to the most recent years in the data set. And that's so it's just we're just gonna do our little graph. So when you open up the code, you click the repit link. This is where it's gonna bring you. So I'm just gonna copy it and then paste over here because I'm working in Jupyter Notebook. So let's go. So I already downloaded the CSV file, so it's on my computer. So then what we're gonna do is we're just gonna read it in. So it's gonna be pd.read CSV, and then it's gonna be, there we go. And then, well, let's take that out. And then what I'm gonna do now is so now that it's red, we're gonna create the scatter plot. So we need an x-axis, which is gonna be the year. And then we're gonna need df dot y-axis. So call it IRO adjusted sea level. Let me just pull this over here so I can read it. There we go. Back over here. And then now, simple fig, comma x equal plt dot subplots. And then set the fig size to so this is equal to 12 comma 12. That should do it. And then x is equal to plt dot scatter, boom, x comma y. So when you run this, we should get the scatter plot. Or no. Oh, my bad. Draw underscore plot. And there we go. So this is the scatter plot as it exists. So now what we gotta do is we gotta create the first line for best fit. So what's that gonna be is this one's gonna be regression, and then it's just gonna be linregress on the x and y. And then what we're gonna do is we can print the result so you can see it. This is the input, or the output rather. So that being said, let's call this f forecast, and then that's gonna be pd dot series, and then that's gonna be I for I in the range 1850 comma 2051. So that's the the forecast. And then I gotta correct this underscore, and then we got the y forecast is equal to the regression dot the slope multiplied by the x forecast, and then add that to the intercept. I think that's, yeah, there we go. I think that's how it's spelled. And then it's just plt.plot, and then x underscore forecast, comma y underscore forecast, comma r. And then what we do is df on, so we're gonna do the forecast is equal to df dot loc, boom, df the year again, the year, and then it's greater than or equal to 2000. Boom. And then, so the new x is now equal to df underscore forecast. So it's gonna be the year of the forecast. So that's YER. And then the new y is equal to df underscore forecast again of that CSIRO. CSIRO adjusted sea level. So what that means, it's calculating the linear regression for the data on the x and y using the linear regression function, and then after we get the slope and the intercept and the other parameters, the result is stored in this right here. Then what we're gonna do is we create a range for the values from 1850 to 2050, and that's gonna be a Pandas series, and it's gonna calculate the corresponding x and y values based on the parameters in this right here. And then we're gonna get the slope and the intercept, and that's gonna create the best fit. So if we run it, we got an invalid syntax. Great. Okay, we get the best fit right here. This is the best fit, right? So then from the best fit, we gotta do the second best fit, which is we're gonna extract the data from the data frame for the years starting from 2000 onward to 2050, and calculate the corresponding y values based on the parameters from the new regression function, or the new regression. So to do that, we're gonna do new regression is equal to linregress, comma new x, and then new y, and then it's gonna be new underscore forecast is equal to, and it's gonna be this line right here. Again, but the thing is, the dates now change from 1850 to 2000, right? And then it's gonna be, well, let's call this new X forecast. Let's call it new X forecast. And then pretty much the same thing for here. We're gonna call this new Y forecast, and then this is gonna be the new reg, and then, well, let's just new underscore, and then that's gonna be new once again. So basically it's the new values, and let's plot it. So again, we'll just copy this, plot it, and then it's gonna be new, and then new, and then we're gonna just change this color to orange, and now we just need to add some labels and some titles, and then that's gonna be plt dot title, and that's gonna be called rise in sea level. That's the name of the chart. And then we gotta do plt dot x label, and that's gonna be, so the x is the year, and the y is the sea level in inches, I believe. So when you run this, let's see, this is now the prediction. So it goes all the way up to 2050. So it's forecasting that with the current data, the sea levels will rise along this path, right? So after it creates the new range, just does the linear regression parameter on the new regression, and then it creates the second best fit. And that's how you do the sea level predictor in free code camps. Data analysis with Python was a very short video. If you like the video, like the video. Comment, subscribe, share, all of that good stuff, I guess. And I'll catch you in the next one. Peace.